Okay, so let's look at functions and some terminology, domain, range, and just the whole concept of mapping diagrams. Okay, so a function is a rule. Okay, so we have we can input a number into the rule, and the numbers we input are known as the domain, or as I say, the IN for inputs. And if we put 1 into the rule, 1 as our x value plus 2, we'll get 3 as our output value, and our output values, all the possible output values are all the output values are the range. Okay, so the domain here is the set of inputs 1, 2, 3, 4, 5, 6 from here, and the range is the set of values which are outputted as a result of inputting these values here. So this is the range, the outputs. And if we take the input value and its corresponding output value, then we get what's known as an ordered pair or couples. Okay, so we have 1, 3, 2, 4, 3, 5, 4, 6, 5, 7, and 6, 8. Okay, and these are the result of a function because none of the input values repeat. So it's not like I have a 6 comma something else here, or a 4 comma something else in my list of ordered pairs. So that tells us that they're the result of a function. And then there's this notion of a codomain. Okay, so we have our domain, which is our set of inputs, and we have our range set of the output. So if we have a rule 2x, our function or our rule is 2x, if x is 1, our output value is 2. And if x is 2, our output value is 4, 2 times 2, and if 3 is 6. So our range is our set of output values. It's the set 2, 4, and 6. But our codomain is all the possible values that were listed in this codomain here. Okay, so 2, 3, 4, 5, 6 were what was listed here, but we only actually landed on 2, 4, and 6 applying our rule. Okay, so the codomain is just known as the list of all possible outcomes or outputs. So let's just look at the notation for a function in maths. The notation function, okay. So the rule for a given function may be written in 3 ways. So if we take this rule 2x plus 4, we can say or write that as f of x equals 2x plus 4, or f is such that x maps onto 2x plus 4, or sometimes I say f colon x goes to 2x plus 4, or maps onto is another term. And the third way we can specify this rule mathematically is we can say y equals 2x plus 4. So we'll look at that further down the line. Okay, so look at this example here. Copy and complete the following table. So you're given a table with input values of -1, 0, 1, and you apply the rule 3 minus 2x, and you'll get your output. So 3 minus 2 times -1 is 5, and here we have 3 and 1. And our couples or our ordered pairs are listed here, -1, 5, 0, 3, 1, 1. Or here's another type of problem we met we were into this chapter. We have f colon x goes to or maps to 6x minus 2 defines a function. If 2 comma a minus 4b, c comma 16, and d minus 14 are couples or ordered pairs as a result of applying that function, find a, b, c, and d. Well, okay. So we write our set of inputs, our domain, as 2, minus 4, c, and d. And we write our range, our outputs, as a, b, 16, minus 14. So we write those here. And we write down our rule, 6x minus 2. And by looking at our rule and seeing that 6 times 2, which is x, minus 2, a must be equal to 10. Or put minus 4 in for x here, we get minus 24 minus 2 is minus 26. And then on this side we have 6 times c for our value of x, minus 2 is equal to 16, so C must be equal to 3, or here 6 times D, minus 2 must be equal to 14, minus 14, D is equal to minus 2. Okay, operations involving functions. So here's an example. Given that the function f of x equals x plus 5, find the value when x is 3. So we just sub 3 into our function. So f of 3 is equal to x, which is 3 plus 5 is equal to 8. Similarly, f of 6, sub in 6 where you see x in the function x plus 5 is 11. F of k, sub in k, where you see x, gives us not x plus 5, but k plus 5. Find 2k. So we sub in 2k where we would have seen x from above, from the function here. So it becomes, x plus 5 becomes 2x plus 5. F of k plus 1, so we have k plus 1 plus 5, actually that's k plus 6 because we gather those like terms there. And f of k squared, well, if f of x equals x plus 5, then we just put in, sub in our value of x, value of k squared, where we see x, get k squared plus 5. Now, here's another example here. If the function f of x, f of x equals 5x minus 2, solve the equations. F of x is equal to 8, okay? So we have to find the value of x if 5x minus 2 is all equal to 8. So 5x is equal to 8 plus 2, x is equal to 2. What about solve the equation f of x equals minus 12? We have f of x up here again, remember? So 5x minus 2 is minus 12. If I keep the x's to one side, bring over 2 becomes plus 2. 5x is minus 12 plus minus 10. X must be equal to 5. Divide by both sides by 5. X is equal to minus 2. Okay? So, slightly more advanced one here, you have to take care. If the function f of x is 5 equals 5x minus 1, find f of 2k minus 1. In other words, sub in this value where you see x here. So f of 2k minus 1 is the same as 5 by x, but x is 2k minus 1 is brackets minus 1. So 5 by 2k is 10k minus 5 minus 1. The answer is 10k minus 6. Now we move on to problems that have two functions. So we have two functions. F of x is 3x minus 2. G of x, the second function, is 2 minus 4x. Solve. F of x is equal to 4. Okay, so that means, let this function all equal to 4. Find x, that's 2. Solve g of x equals minus 10. Let all of this function equal to minus 10, and you'll find that x is equal to 3. And now we're asked to solve g of x is equal to f of 4. Well, first we have to find what's f of 4. So we take the f of x function and we throw in or substitute in 4 where we see x. So it's 3x minus 2. So that's 3 times 4 minus 2. F of 4 is equal to 10. And g of x from the original from above is equal to 2 minus 4x. So now what we're actually solving, g of x is equal to f of 4. We're actually saying that g of x is equal to f of 4. That's what we're looking to solve. G of x is 2x minus 4. That's all equal to 10, which we found earlier here. So if we solve that, you'll get x is equal to minus 2.